Good morning, Junior 4. It's a math session. Our lesson today is talking about congruency. First, let's know what the meaning of the word congruency. Here I have two polygons like this. The first polygon called A, B, C, D, E. And the second polygon called X, Y, Z, N, L. If I want to prove the congruency of the two polygons, I should prove that the two polygons are twins. I mean, the two polygons are similar polygons. I have two conditions to prove the congruency of the two polygons. First, their corresponding sides are equal in length. I mean, the first side here is called AB. What is the corresponding side for it in the other polygon? It's called XY. If AB equal XY and BC equal YZ and CD equal ZN, then DE equal NL, and finally AE equal XL. So I prove the first condition. The second, I want to prove that corresponding angles are equal in measure. Angle A should be equal to X. If I have that angle A equal in measure the angle X and the angle B equal the angle Y, the angle C equal the angle X, and angle D equal the angle N, and the angle E equal angle L. So I can say that the polygon ABCDE congruent to the polygon XYZNL. So I can write this step as, if I have AB equal to XY and BC equal YZ and CD equal ZN. And DE equal NL, and finally EA equal LX, and the measure of the angle A equal the measure of angle X, measure of angle B equal the measure of angle Y, and the measure of angle C equal the measure of angle Z, and the measure of angle D equal the measure of angle N, Then the measure of angle E equal the measure of angle L. Finally, the measure of angle A. Now, I proved the two conditions. The corresponding sides are equal in length and the corresponding angles are equal in measure. So, I can say now that the polygon A, B, C, D, E congruent to the polygon X, Y, Z, and L. This is the sign of congruency. But remember, we should write the polygon, the letters of the polygon, congruent to the same order of the letters the other polygon. I mean, if we start with the polygon A, B, C, D, E, congruent, write the letters in order to the first polygon. We start here from the letter A, so we start the second polygon from the letter X. Then we take the letter B, so we will take the corresponding letter, which is Y. And if we take the letter C, we take the corresponding letter, which is Z. And the letter D, the corresponding letter is N. Finally, the letter E is corresponding to the letter L. We should write in the same order. On the other hand, if we have two polygons are congruent, we know that the two polygons are congruent. Then each side and each angle in one of them is congruent to its corresponding element in the other polygon. For example, if we have the polygon A, B, C and the polygon X, Y, Z, if we know that the polygon A, B, C is congruent to the polygon X, Y, Z, the polygon A, B, C is congruent to the polygon X, Y, Z. Then we get that each side in this polygon is equal the corresponding side in the other polygon. I mean, if we call this letter 1, 2, 3. Okay? And in the other polygon X, Y, Z, 1, 2, 3, because we have 3 letters here and 3 letters here. We get that the side AB is corresponding to the side X, Y. To make sure that this side is corresponding to this side, we look at the letters here. If we take the side AB, I mean the first and the second letter, we should take the first and the second letter from the second polygon. AB 1, 2, XY 1, 2. So we write AB congruent or equal XY. And now we take other side. BC. BC here is the letters number 2 and 3. So I will take the letters number 2 and 3 in the second polygon, which are YZ. YZ, this side. So I can write that BC is congruent or equal to the side YZ. And the last side is AC. AC is number 1 and 3. So I will take the letters 1 and 3 in the second polygon, which are xz. So I can write that the side AC is equal to the side xz. AC equal to the side xz. Now we look at the angles. The angle A is congruent or equal to the angle X. If I take the first letter here, angle number 1, so I will take the angle number 1 also. So I can write that the measure of angle A equal measure of angle X. If I take the angle number 2, which is B in the first polygon, so I will take the angle number 2 in the second polygon, which is Y. So I can get that the measure of angle B equal to the measure of angle Y. Finally, the measure of angle number 3, which is C, is equal to the measure of angle 3 in the second polygon, which is Z. We have 3 special cases for 3 shapes. Make the congruence easier. First shape is square. If we have 2 squares like this, we only need one condition to make them congruent. So we can say that 2 squares are congruent if the side length of one of them equals to the side length of the other. I need only one condition because I don't need to prove the equality of angles, because we know that all the angles in all squares are right angles. All the angles here are 90 degrees. So I don't need to prove the equality of angles. But I only need to prove that one side is equal to the other corresponding side in the other polygon. So if we have the first side in this polygon, AB, if we have AB, the side AB equal the side XY, so we can say that the polygon A, B, C, D congruent to the shape or the polygon X, Y, Z, L. And remember the order of the letters. I start from A, so start with X. Then B, so Y, C corresponding to Z, and D corresponding to L. So A, B, C, D congruent to the polygon X, Y, Z, L. The case number 2 is for rectangles. If we have 2 rectangles like X, Y, Z, L and A, B, C, D, we can say that 2 rectangles are congruent if 2 dimensions, the 2 dimensions, length and width of one of them equal to the 2 dimensions of the other. I mean, if we have this polygon called X, Y, Z, L, and this shape, this polygon called A, B, C, D. We put the numbers on the letters 1, 2, 3, 4. 1, 2, 3, 4. And if we have the side XY, which is the letters 1 and 2, if we have the side xy equal the corresponding side here. Can I write BC? No. We take the first and the second letter here. We take here number 1 and 2, xy. So I will take 1 and 2, which is AB. If we have xy equal AB and the other dimension, which is yz, equal yz here is number 2 and 3. So I will take the number 2 and 3 in the other polygon, which is BC. If we have xy equal AB and yz equal BC, we prove that the two dimensions are equal. The second condition is about the angles. We don't need to prove the equality of angles because all the angles in all rectangles are 90 degrees. So I can say here that the polygon x, y, z, L congruent to the polygon A, B, C, D. The third case is for triangles. Any two triangles are congruent if each side is congruent to its corresponding side in the other triangle. Here I want to prove only the condition of the sides. First, I have the triangle A, B, C and the triangle X, and we start here from A, then X. Number 2, I take B, so I will take Y. Then I take C, so I will take Z. 1, 2, 3, and 1, 2, 3. If we have AB, the side AB equal to the side 1 and 2, so I will take 1 and 2 here, equal to the side XY. And the side BC, I take number 2 and 3. BC equal to 2 and 3 here is YZ. BC equal to YZ. And AC, which are 1 and 3, so I will take 1 and 3 here, which is XZ. AC equal to XZ. Now I have all the sides here are equal to the corresponding sides in the other polygon. I don't need to prove the equality of the angles because in the triangles, if we have the three sides are equal, it leads to make the angles are equal. So I can say that the triangle A, B, C congruent to the triangle X, Y, Z. Now open your booklet page 34. Remember that two congruent polygons should be written in the same order of their corresponding vertices. In the first question we have, in the opposite figure, the polygon ABC is congruent to the polygon XYZ. Remember to put the numbers first. ABC, which is 1, 2, 3, congruent to XYZ, we put 1, 2, 3 also. So now complete, we want to measure of the angle Z. The measure of the angle Z. The angle Z here is the angle number 2. So it will be equal to the angle number 2 here, which is B. B here is 90 degrees, and Z is congruent to the angle B, so Z equal 90 degrees also. Number B, I want the measure of the angle Y equal how many degrees? The angle Y is here. We should remember that the sum of the angles of the triangle equal 180. So, if I want the third angle, I will take the sum of the angles and minus 40 and 90. The sum of the two other angles, 180 minus 40 plus 90. 180 degree minus 40 degree plus 90 degree. First 40 plus 90 equal 130 degree. So now we should want 180 minus 130. It will be 50 degree. So the angle Y equal 50 degree. I want to know the measure of the angle A. The angle A is the first angle, number 1 here. So I will take, it will be equal to the first angle in the second polygon, which is X. X is equal 40, X equal 40 degrees. So A congruent to X, then A will be 40 degrees too. Now I want the measure of the angle C. C is the third angle. So it will be equal to the third letter here, which is Y. C congruent to Y. So C equal 50 degrees. Question number 2 in the opposite figure. If the triangle ABC congruent to the triangle XYZ, then complete. First, we should put the numbers. 1, 2, 3. Here, 1, 2, 3. And now, we want to know XZ equal how many centimeters? So, we will look at the numbers. XZ here, which is 1 and 2. So, we will take 1 and 2 here, which is AB. AB here equal 5 centimeters. So XZ is congruent to AB, and then XZ equal 5 centimeters too. Now we'll take the second question. Number B. I want to know AC equal how many centimeters? We look at the numbers. AC, which is 1 and 3. So I will take 1 and 3. AC is congruent to XY. Where is XY here? XY here is 3 centimeters. AC is congruent to XY, then AC equal 3 centimeters. Number C, we want the perimeter of the triangle ABC. The perimeter of any triangle equal the sum of its side lengths. So, I will get all the sides of the triangle ABC. We have here AB equal 5 centimeters, BC equal 7 centimeters. I want to know the side AC. AC here equals 3 the parameter means we get the sum. 3 plus 7 plus 5. 3 plus 7 equal 10. 10 plus 5 equal 15. That means the parameter of the triangle ABC equal 15 centimeters. Complete. Number 1, two polygons are congruent if their corresponding sides are what? In length, and their corresponding angles are what? In measures. We have two conditions: equality of sides and equality of angles. So, two polygons are congruent if their corresponding sides are equal in length and their corresponding angles are equal in measure. Number 2, two squares. We have a special case here. Two squares are congruent if the side length of one of them is dots to the side length of the other. The side length of the one of them equal to the side length of the other. Now open your booklet page 35 and look to the question number 3. Two rectangles are congruent if two dimensions of one of them are what? To the two dimensions of the other. So we have two rectangles are congruent if two dimensions of one of them are equal to the two dimensions of the other. Number 4, any two triangles are congruent to triangles. A special case. Congruent if each what is congruent to corresponding side in the other triangle. So, any two triangles are congruent if each side is congruent to the corresponding side in the other triangle. Number 5. A diagonal of the rectangle divides it into two what? Triangles. If I have a triangle here and its diagonal like this, the diagonal divides it into two similar triangles, means two congruent triangles. Number 6. If the triangle ABC congruent to the triangle RST, then the angle B is congruent to which angle? We put the numbers to make it easy. 1, 2, 3, 1, 2, 3. So I want the angle B, which is number 2, is congruent to the number 2 here, which is the angle S. Put right or wrong. Number 1, two rectangles are congruent if the two dimensions of one of them equal to the dimensions of the other. Yes, it's right. Number 2, two polygons are, this is two polygons. It's not a special case. It's two polygons. Are congruent if their corresponding angles have the same measure. In this question, I have only one condition. It's not enough. I should get the two conditions, the corresponding angles, the equality of the corresponding angles, and the equality of the corresponding sides. So, it's wrong. I need the equality of sides. Number 3, two squares, and it's a special case, are congruent if the side length of one of them equals to the side length of the other. Yes, it's right. Number 4, a scaling triangle can be congruent to an isosceles triangle. are twins and it's the isosceles triangle? No. So it's wrong. Any two squares are congruent? No, it's wrong. I need to make sure that one side of them is equal to the corresponding side of the other square. Number 6, a square of side length 3 centimeters can be congruent to a rectangle of dimensions 3 and 4 centimeters. I can say that a square is congruent to a rectangle, so it's wrong. Number 7, two triangles are congruent if each side length of one of them equals to the corresponding side length of the other. Yes, it's right. The last one, any two equilateral triangles are congruent? No, I need to make sure that each side is equal to the corresponding side in the other triangle.